Hi there, this is Penelope, and this is a short video for MG5004 or DE5418 explaining what it is that I talk about when I mention Pascal's triangle. Now, Pascal's triangle is not part of the course. It's to do with statistics and binomial theorems and stuff, but what we call the expansion of it really helps us figure out how to expand something plus something to the power of a bigger number than we can actually kind of cope with. And it just makes life so much easier. We don't have to work it out each time. We don't have to, if we've got to the power of 4, we don't have to work out multiplying 4 brackets together, or heavens above, what about 6 brackets? We can just write it straight out from knowing the pattern, because that's all it is it's a pattern. Now, here's what it looks like for some lines. It's just a pattern. It has ones down the outside, on each side. So you fill in your ones down the outside, and then the inner numbers are worked out from saying 1 plus 1 gives you 2. Now on the next line, we've got to go 1 plus 2 gives us 3. 2 plus 1 gives us 3. On the next line, 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. Next line, 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. On the next line, 1 plus 5 gives us 6. 5 plus 10 gives us 15. 10 plus 10 gives us 20. 10 plus 5 gives us 15. And 5 plus 1 gives us 6. That's just how it looks, all right? Those are just at this stage numbers that you can see there how they're worked out from the previous line. Just put in your ones down the outside and then continuously add up pairs of numbers as you go through. Okay, but what can we use it for? Now, line 7 from that triangle goes 1, 6, 15, 20, 15, 6, 1. What we use those for is for finding the coefficients when we expand a plus b to the power of 6. So we've got a plus b to the power of 6 is going to be 1 times something or other, plus 6 times something, plus 15 times something, plus 20 times something, plus 15, plus 6, squished 1 times something. So each of those numbers are from the triangle. That's from the triangle, 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 triangle. Okay, that's clearly not totally helpful, but if we know a little bit more, then we can find out the bits where I've just said 1 times something or 6 times something. Remember, all it is a tool to help us expand a plus b to the power of 6 really quickly. Okay, now we know how to work out a plus b squared. We know that it's going to be, if we did it the long way, and then it would be a squared plus ab plus ba plus b squared, which is equal to a squared plus 2ab plus b squared. Now, if you look back at the triangle, let's just go back a couple of slides for the second line. Look, here it is here. Let's make it red. So this line here has the pattern of the coefficients 1, 2, 1. So let's move forward. So that's where it is there. It has the coefficients of 1, 2, and 1. Okay. If we're going to do the same for the next one, we would have had to multiply out a plus b times that, and we would have got a cubed plus 3a squared b plus 3ab squared plus b cubed. So again, the coefficients are from the table: 1, 3, 3, and 1. So we could have started out by just putting in the coefficients 1, 3, 3, 1 from the table, and we would have got part of the way. But now let's have a look at how we can finish off this shortcut without actually working it. You can probably guess that the first number, the first power of a has got to be a cubed. So that's fine. And there's no b's. But what if I said, well, just to make it easy to think this through, we put in there, in blue, b to the power of 0. And then in the next one, I write the power of b that we don't need to write, but it's b to the power of 1. And in the next term, I write a to the power of 1. And in the last term, I squeeze in there a to the power of 0. Now, what we're doing next, remember it's only a shortcut, and we can't actually do this, but that the powers of a and b add to 3, which is the expansion we're making. We're doing the cubed, even though we're actually not doing this. Because we can only add the powers if the numbers are the same. But for this shortcut method, that's what we're doing. Now, you don't need to write in the red numbers, and you don't need to write in the blue numbers, so the answer was just a cubed plus 3a squared b. But you can see in the second term we've got square a and 1b. They add up to 3. In the third term we've got the power of 1 of a and b is squared, so it adds up to 3. Each time the powers add up to 3. So we said then 3ab squared plus b cubed. This is how I can write out these expansions really, really quickly. I'm not working them out. I'm just remembering the pattern. Okay, let's go for a big one. Let's go for a plus b to the power of 6. Okay, I'm going to write in my coefficients first. So going back to the very first one, they're going to be 1, 6, 15, 20, 15, 6, and 1. Okay, and each of them is just going to be plus all the way through. So the first one is going to be a to the 6, b to the 0, plus a to the 5, b to the 1, plus a to the 4, b to the 2, plus a to the 3, b to the 3, plus a to the 2, b to the 4, plus 6a b to the power of 5, plus 1 a to the power of 0, b to the power of 6. Now, I can tidy that up. There are some things in there I don't need, but I can just take out the 1 and the b to the power of 0, because b to the power of 0 is 1. 6a to the 5. Now, I don't need to write b to the power of 1. I can just write b plus 15 a to the power of 4, b to the power of 2, plus 20 a cubed b cubed, plus 15 a squared b to the 4th, plus 6a b to the 5, plus, now I don't need the 1, I don't need the a to the 0, I just need b to the power of 6. It just takes me as long to write it down. I'm not thinking because I know the pattern. All right, that's why. But what we've been using it in the course for is some complex number stuff where we've had to expand that. Now, when I've done these, I've said, if you write out the word cos and the word sine, your lines are just going to be far too long. So we could just write it as c plus js to the power of 6. So c is equivalent to cos and s is equivalent to sine. Now, what we also need to remember is that j squared is -1, j cubed equals negative j, j to the 4th equals 1, j to the 5th equals j, and j to the 6th is going to equal -1. Okay, so we just need to remember all of those. Okay, so then we can just start writing. So c plus js to the power of, I don't know why it does that. Let's just move you down there. Right, c plus js to the power of 6 is equal to c to the power of 6 plus 6c to the power of 5. Now we just have to be careful. The other term this time, the equivalent of b, is to the power of 1 plus 15c to the power of 4 times js to the power of 2 plus 20c cubed times js to the power of 3. Just going to put that over there. Plus, where are we up to? 15c squared js to the power of 4 plus 6c js to the power of 5 plus, well, there's no more 6, there's no more c, so it'll just be js to the power of 6. And if we rearrange that, deal with all the j's, then we end up with c to the power of 6 minus 15c to the power of 4 s squared plus 15c squared s to the power of 4 minus s to the power of 6 plus j times 6c s5 minus 20c cubed s cubed plus 6c to the 5s. Now remember, what we were doing these for is to find something like what is cos to the power of 6 or something. So we did need to use that other theorem that says cos x plus j sine x to the power of 6 is equal to cos 6x plus j sine 6x. And as those two things are equal, then cos 6x must have been equal to cos 6x minus 15 cos 4x sine squared x plus 15 cos squared x sine to the 4x minus sine to the 6x, and comparing then the imaginary bit. The imaginary bit will give us that sine 6x is going to be equal to 6 cos x sine to the power of 5 minus 20 cos cubed sine cubed plus 6 cos to the 5 sine x. And then depending on what you've been asked to do, if you were asked to find sine to the power of 6, you'd rearrange it, and depending how the answer was formatted, you're going to have to repeatedly use some trig identities, things like sine to the power of 6 is sine squared to the power of 3, cos squared is 1 minus sine squared, cos 2 theta is cos squared minus sine squared, all those sorts of things that are in your list. You just have to keep putting them in until you get your answer to look like what the question has required you. This one just said expand it, or find cos 6x, or find sine x, whatever, it doesn't matter. But there's not much to this question other than showing you how quickly you can expand big lots of brackets. Okay, thanks for watching.